Good afternoon to you all. Yesterday we discussed about the HVAC, how to do heat load calculations and cooling load calculations. So generally what will happen after calculating the loads, we will distribute the air terminals according to required flow. In today's session, we are going to how to do duct routing and what kind of fittings we are going to use and how we can do automated duct routing. These things I'm going to cover today. Before going to duct routing, just I would like to explain how to read the drawing of HVAC. So I would like to show one sample drawings to you. I hope everybody can see this drawing. Okay, this is belongs to one hospital. So this drawing is done in basic detailing, basic engineering level. As we know, we have the different stages in designing: schematic designing, basic designing, and detail engineering, and construction or fabrication designing, and as-builts. This drawing belongs to basic engineering. So if we observe this drawing, just we can see only single line diagrams with appropriate features. See, if you take this area, okay, this is, as we discussed yesterday, arrows are indicating towards diffuser. This means written. Okay. Here, see, this is the diffuser of supply. Arrows are indicating towards room. This is the AHU, means air handling unit. Okay. Here in basic engineering level, we have not calculated and updated airflow. See, this supply is coming from this AHU and going into different rooms. Okay. See, if you observe the things, here we have the supply and simultaneously return. Okay. Again, it's going to HU. Here, if you see terminology, SCA means supplied air, and RA means return air. For this room, supply air is 100 CFM, return air is 90 CFM. And if you think here, we are supplying 100 and giving the return to 90 CFM. So what about the 10 CFM? This 10 CFM, we have the losses due to infiltration. We have giving the positive pressure to this room. Because of positive pressure, this inside conditioner will be go out through gaps. Okay. Again, if we observe this HU, here we have the two pipe connections. We should recall for each HU should connect with chilled water supply and chilled water return. And these are the symbols for valves. See, this is electrical room. And here giving the supply in with different formats. We call these kind of things air showers. So we can find here VCD, volume control damper. See here, if you observe the things, this is the electrical room and we are giving the diffuser here, okay, above the room. Why don't we give in between the room like this room and this rooms? Because in sometimes there is a possibility to leakage of conditioned air which is passing in duct. So we will have very less quantity of condensed water, even though we should take care about in electrical rooms to avoid the short circuits. See, this is AHU and this is duct 600 by 400 width and height of the duct. First we will consider width and second height. And again it will go into this room here 350 by 200 and again VAV, VAV, VAV. I think you should remember what is VAV. VAV is the variable air volume. Generally, in each room we will place with one thermostat and we will fix controlling temperature. After reaching the required temperature, VAV will make control the flow of the air. So variable air volume, we can see meaning in this one only. For example, if you want continuous flow, whether it's cool or hot, we will use CAV, constant air volume. For commercial and residential thing, most of the cases we use VAV only. If you see operation theaters and clean rooms, we use CAVs, and same way we will control the airflow also. If you see this room, supplier is 400 CFM. So this is the way to read the HVAC single line diagrams or basic engineering level. I hope it will be clear to what is how we do in basic engineering level of HVAC. See, now I'm going to Revit. How we do in Revit? New project, and I'm going for system default metric. As we know, in system we will have that electrical, plumbing and mechanical. Here what I'm doing is same drawing I would like to import in Revit for our better understanding. Before going to explain about this drawing how to do, just I will give the basic information of the HVAC, how we will place the diffusers and how we will do auto routing and all. In systems, we have the air terminals. Okay. Here is a supply diffuser. Air terminals, I want to place the see, this is supply and this is the return. Okay. If I select the diffuser, I can see symbol like this. This called supply. Okay. And if I select this, we can see symbol like this. This is a return. Before doing the duct routing, I should create the system. We have the different kind of the systems in HVAC like supply, return, exhaust, and fresh air. See here I am going to create the supply network first for your better understanding. Okay. As we know, this diffuser is the one component. Here we can get one doubt. How we can classify whether it's a return or supply? Just if we select and edit family, we will find one connector here. Most of the MEP components depends on this connector. If we select this connector, here we can see the properties. Here, system classification is the supply. Okay, shape is a rectangle. So remember this point. For example, if I change it to supply to return, it will behave as a return diffuser. Just a moment, let me open return also. So return here. Here shape and geometry, it's purely to identify the things only. Okay, we can change as we required. For example, I am going to take one duct here, size whatever it may be. Just and I want to draw a duct from this diffuser. When I place my cursor on this diffuser, you will get the node. Just drawn it. In blue color, we are getting the duct. In same way, I'm taking same duct. Okay, same sizes, same properties. I'm not changing any properties. Just I'm selecting the diffuser, drawing it. What is happening? It became into return. Why? Okay, always it will take from this connector. If connector is supply, duct will come as a supply. If connector is written, duct will come as written. So most of the classification will done here only. Okay. I'm copying this supply. Supply. Okay. Here I want to create one specific system for this for supply systems. To create the system, I need to select the diffuser and create the system. Okay, I selected create the system. I'm going to create the system type supply and system name. I can give any. Let's say HU1. I'm going to connect this to HU1. Now it became diffuser in supply system. So if I want to select the system, just I need to place the mouse and need to hit the tab and select it, edit system. So what I'm going to here is I want to add this other three supply diffuser into same system. Okay, add the system. Okay, finish. Hit the tab, I will get all is become as one group. Okay. If I press the F9 function key 9, I will get the system browser. Say I have the system supplier and returner. Okay. See, I created the system AHU. Okay. AHU. See, here is flow showing 940. If we take individual one, flow is 235. If I make it into 500, in system also it will change. Okay. So now it's become 2000 liters per second. Okay. We use the systems in different purpose, but as of moment, I'm stopping about these systems because we need to study more about these systems. Okay, it may make some confusion. That's why just to identify total flow and to create the auto duct routing, I'm showing about these systems. Okay, just I am closing it. Here now I have one system. Okay, I selected the system and going to layout, generate layout. Okay. So when we do this kind of processes, for example, I am the HVAC engineer. I want to do my own design in schematic to whatever it may be. On that time only, I will use this kind of things. Generally, in BIM industry, we get the AutoCAD drawings as is shown like this, and we will insert this drawing into our Revit. We will start capturing and creating the 3D model. See, just if I get this auto routing, here I have the different solutions. One is a network and is a perimeter and is a intersection method. In network, everything will connect in network basis, and if you take the perimeter, it will show the perimeters of this room and at intersections. Sometimes intersects with the diffusers. Okay, most of the times we use network only. Okay, and again here it will show different options. This is a one option, this is a second option. So one option. Okay, here we have the settings. Main duct and branch duct setting. If you click on the main duct, it's a duct type, whether we need to use rectangular or round, and offset of this duct. This offset means from floor to bottom of the duct height or center of the duct height. We take the branch duct. I'm going to take round duct tap. See here we have the tap and T. I will explain clearly about once again about the tap and T. Just I'm taking round duct. I will explain. Here maximum length of the flex duct. Yesterday we discussed maximum length should be less than 1 meter. It's a most economical thing. Okay. Now I'm going to give the finish. See. Fine. Shaded. This is I created. Here what happened? This duct has taken as a main duct, and these three ducts are taken branch ducts and flexible duct also. Okay. For example, I have the shaft somewhere else. Okay, duct is coming from this bottom or lower floor. Here we have the place base. Okay, I will place the base point somewhere here. Okay, if you go to solutions, now it will give the more solutions. Okay, I feel this is a comfortable. Then I will go with finish. Now, if you see in 3D, these are taken as branch duct, and this is a main duct. Okay. Here we will discuss about the what is tap and what is a T. For example, if I select this duct here, this duct type is a tap. Okay, this is a T. Here I'm selecting the duct and right click, create similar. Means I will get duct with same property of this duct. See, I'm going to draw one duct. Create similar. I'm going to draw another duct here. See the difference. Tap is to connecting to the main duct and T is connecting with other component called T. Okay. Here we have the connection called take off tap. Sometimes here we can find the preferences of the duct. Okay. For example, I want to create new type. Edit type, duplicate, same like architecture some things. I will give something name. Preferences here. Elbow. Okay. What type of elbow we need to use? T or tap. Junction. T. Okay. This is a junction type and this is junction. They are a cross. If the two ducts will cross, what we need to use? Transition means reducer. Okay. Multi-shape transition, rectangular to round, rectangular to oval. Wherever we are selecting these are the families, Revit families. Here I am going to change into tab and here I am getting the take up. In take up I am getting one take up and T. Okay. Why I am getting T here? For this duct type I created in preferences, it's a tab. Okay. I'm going to create another type of the duct. Edit type, duct 3 or some duct 2. Preferences with tab or T. Create the similar duct 2 type is getting the T. Insert. If you want to load new families, load family. See. Program data. Autodesk, libraries, India, duct, fittings, rectangular, T, transitions, elbows. Okay, here I am going to load this T with bevel. Okay, Control C, edit type. I will get the beveled. Create similar. See difference here. This kind of structure we call as beveled. See, while doing duct routing, we should concentrate about this. For example, our air is coming like this from AHU. Okay, this flow should be like this to avoid the friction loss. See, if I take one duct, create, I want to discuss about the different kind of fittings. Okay, first, if we aware about the fittings, routing will be easy. Okay, I want to cross one duct here, and I'm going to draw another duct here. I want to connect to here. Okay, if I select any object, we will get the contextual modifier button. Okay, these modify commands all are same to architecture and structure. Okay, if I take extend, selected and extending, automatically I will get the T connection. So for if we see this routing, we have one elbow, T. See, if I take the one branch, I'm getting the T, and systems, if I select the duct 2, I will get it beveled because I created type with this kind of settings. We have the different kind of fittings here. Okay, based on the shape, we have the different kind of fittings. See here, for example, this is radius elbow. Okay, I want to get into meter elbow. Just I need to select it and go into meter elbow. Okay, it's a rectangular one, no? Rectangular meter elbow. With the help of this meter elbow, friction loss will be more. if there is any space, we should go with meter elbows. And we can change radius of the elbow also. We have different kind of types. Radius elbows 1, 1.5, 2. It's a 1. If you see this elbow family, a date elbow, and here again we will get the connectors. Okay. Here we have the different properties. If you want to change the radius of the elbow, you can change into radius factor here. If you see 1.5, here radius factor, sorry, radius multiplier is a 1.5. If you place 1, it will become 1. Okay, we need to create the different type, and according to our requirement we can change it. Okay, and so now we discuss about this, how to create the auto routing and different kind of fittings. Okay, here we may get one doubt. I want to create one Y fitting. Okay, that like this. Yesterday we seen in photographs like this, and this I want to place one Y fitting here instead of T. Okay, so then we need to load that family. Inside load family, duct fittings, and rectangular. Now we are working on this. This is a Y. Okay, open, load it, and systems component, go with just place end of the duct. Okay, according to duct size it will change. Even we can change our settings here also. Generally we use this Y fittings for bigger size of this ducts only. Okay, and if you want draw the duct from this, and systems duct, see automatically duct size will be changed. Systems duct, I'm taking 300 by 300 duct. Okay, just if I see here we have the 450 by 450 duct. Okay, right click, draw duct like this. Why it's changing automatically? If we edit this family, we have the different connectors here. If we select the connector property, here we have the height, width. Okay, these things we will merge with some mathematical calculations. Okay, depth of the right, width of the right. Okay, here this will change automatically. See, I will show to understanding in simple family. If we take one elbow to select the connector, here height, duct height. Okay, if we take the width, duct width, it means automatically these dimensions, height and width, will change according to the duct sizes. I hope you understood. See, for example, now I'm going to draw one duct with different sizes, like we can say 450 by 450. Another duct, I will take some bigger one, 1000 by 1000. See, here what is happening, size of the elbow is changing and we have the bigger size of the duct. Automatically we are getting the reducer. Okay, in practical way, if you observe, to connect the smaller size to bigger size, we should have the reducer. See, this is my duct 1000 by 1000. Okay, again I'm going to draw one duct 450 by 450. See, end of the duct, what will happen? Automatically I will get the radius, some reducer or transition. It's a based on angle also, we can change the transitions. These are the standard reducers in market. Say if I take the 15 angle, it will length of the transition will be increase. The 16, it will be reduce. Okay. See here, this is rectangular. I'm going to take 16. Now, for example, I want to change this duct into a round duct. Okay, just select the duct and I change it. What will happen? Automatically, transition will change. So rectangular to round. Okay, and before going to draw one duct, we should concentrate about in which level we are going to draw and what is the width of the duct and is the height of the duct and offset of the duct. Offset means floor to duct or whether bottom or center based on the justification. Here if I take one duct here, say here I will take one section. Go to fine. Okay. Here why I'm not getting levels is elevation symbols. Okay. Somewhere small, looks very small. I'm going to draw somewhere here. This is my section. Level 1 to 2 is a 4-meter height. Okay. If I measure the duct here, this is called as bottom of the duct. Okay. This is called as top of the duct. So I'm taking one duct here. I'm going to draw. This justification is middle. Offset is this much. Vertical justification means bottom. Okay. What is 2975? I taken this duct justification as bottom. Okay. So it is taking as bottom of the duct. While drawing the HVAC layout, we should concentrate about the whether we need to draw bottom of the duct or top of the duct. See, again I am going to draw one duct here. Create similar and changing the 200 by 200. So if I connect these two ducts, I am getting some duct 200 by 200. This is I'm getting this kind of reducer called as concentric. For example, I want to get the eccentric reducer. What I need to do? So simply I'm deleting it. Just we need to align side of the ducts. You will get the eccentric ducts reducers. Okay. So now we know what are the different kind of fittings we are getting, how we need to place. Okay. Here I'm going to insert one AHU, air handling unit. Okay. Insert load family. I have my AHU family here. AHU opening. Systems component AHU. Just I'm placing H here. See here. Now we are clear how to create the system and how to place the air terminals and how to we use different kind of fittings. Okay, we should more concentrate about this beveled connectivities because most of the rectangular ducts we use this kind of connectivities. It should be faced towards flow of the towards air direction flow. I'm going to delete these things. Generally, we have the AHU like this. Okay, this is supply. For each AHU, as we discussed, this is supply. Okay, and it's a return. One is exhaust or fresh air, and different pipe connections. Okay, chilled water supply, chilled water return, chilled water supply, chilled water return. This is the drain connectivity to draw the pipe. With these coils only, we will get the coolness. If we edit this family, say this is the supply. This is we place in others based on the purpose. Okay. This is return. For example, I'm selecting this air handling unit and run the duct. Okay. So I'm getting size in different. What is 2200 plus 1655? If I change this duct sizes into different sizes, I will get the reducers like this. Okay, this is supply duct. See, if I draw duct from this, say I selected HU, here I'm unable to select the duct connector. So in this case, what we need to do is we should take the section. While doing MEP, section will be play major role. Like this. See, this is a supply and this is a return. If we change the duct size, we'll get the reducers. Okay. From this AHU only, we will make the routing. If we place the air terminals, return, I'm placing this side. Go to view. Where we are able to placing this. I will move a little bit outside. Go to view. See, when we are placing the air terminal, automatically it's taking level. So, but we need to place this air tunnel to ceiling. So, before starting the MEP project, we need to link the our architectural model. Okay. In our architectural model, we will have the ceilings. So we need to place this ceiling diffusers to ceiling. Now I not inserted this architectural model. Just I'm explaining about this HVS only. That's why not inserted. Even though if I want to change this diffusers into ceiling level, just we need to select the diffuser and here we need to go the offset. Let's say 2500. If you see in 3D, we'll get this. If I selected it, offset should be 2500. 2500. Okay. See. Now I want to create the return system. Initially we have created supply. In same way, I would like to show return system. Select and that. Okay. Return. So we can give any name here. And again, edit system, add to system. Finish. Okay. Here I would like to place the routing manually. I can do automatically, auto routing also like this, but I want to route in manual method. Just I'm taking the duct. If I select the return diffuser, here I am going to get the 300 by 300. Okay. If I draw duct from here, I will get the 300 by 300. See here. Here I am taking the duct. One standard. I will take meter elbow and tap. See here. I'm going to draw like this. That sizes I'm taking. Let's say 400 by 300. I'm connecting to this edge. Okay, now we are taking meter elbow. Say difference. Okay, it's connecting to down. I want to check the height of this thing. Okay. Why it's showing down? I have taken that elevation as 100. Okay. So I want to change the duct elevation. I need to disconnect. Please remember this point. If you want change the duct elevations, you disconnect somewhere. Otherwise, all elevation will be going to the change. Mostly this will use to create in coordination with other services. We will discuss later about that one. Now I want to change the offset of this duct. See, I place the mouse on the duct, I hit the tab and selected. Same times I am changing it to 3200. Okay. Now I am going to trim here. T or modify commands. See the difference. Okay. Here I have the return diffusers. I need to connect these return diffusers to this duct. Here we have one option called connecting. Okay, connect into. I'm selecting the diffuser, connect into, select to duct. Automatically I will get the routing here. Selected, connect into, selected, connect into routing. Selected, connect into routing. Okay, so now see, I got the connectivity. Okay, so here, so today I would like to close the session a little bit earlier. We will continue by tomorrow. Before that, I want to explain thing. We need to connect the diffuser and duct with flexible connectivity. How? I need to change this duct into flexible. See, here we have the option called convert to flex duct. It's a mandatory. We know when we are going to connect any equipment with duct, we should use a flexible duct. So I'm going to convert to flex. Okay, maximum length of the duct. I will take just 500 only. Selected duct diffusers. Okay, now we can see flexible duct connectivity. Okay. And here we can remember one thing. Just I'm going to place one diffuser return with elevation something 2000. Okay, here I am placing, for example, okay, select a diffuser, connect into. If I connect like this, I will get this duct only. Okay, here I want to draw completely with flexible duct. Okay, here I have the option flexible duct, but before this I need to draw some duct. Okay, then need to flexible from here to here. This length is more than 900 something. Okay, what we need to remember here is we can draw flexible duct in plan only. Okay, just I'm going back. I'm going to take one section here. Okay, for example, my duct is here. Okay, see here. If I come into the section, these are not visible. So based on this, what we understood that we should draw flexible duct in plan view only. See here I have taken supply duct. That's why it's taking wrong. Duct. Okay. In this way, we can do duct routing. And in tomorrow session, we will discuss more about this workflow. how we do and what kind of fittings and how we identify the features in our drawing. So we will discuss more about it, and we will simultaneously will start some plumbing part. So today I am going to close the session because of some important meeting. Thank you.
Yes, so I'm just going to check with each location. Anju, how did you actually find today's session?
So it's quite useful. We learned a lot. I think my team has also learned a lot about the MEP and how to draw. I mean, how to do the routing and all the duct fittings. So
Okay,
yeah.
okay. That's good. I hope you're talking for everybody there in Delhi.
Yes, sir. Yes, definitely, sir. For
Okay,
everyone.
okay. And next, I would like to actually, what do you say, check with maybe with Sheetal. What about Mumbai? Was it okay?
Yeah, it was very much fine. It was,
Okay. Was the pace and everything
yeah,
okay, Sheetal?
yes, yes, definitely.
Okay. What about Kritika? Mumbai, was it okay, Kritika, today?
Yeah,
Was it
yes, sir.
useful?
Yes, sir. Yes, sir.
And what about Irfan? The pace was okay. Could
Yes,
you?
sir. Absolutely fine, sir.
Okay, okay, fantastic. Let me now go to Bangalore. Niranjan and team there, was it okay?
Yes, sir. Okay, sir.
Okay, was the pace okay or was it an overload?
A little bit just louder you should speak, sir. It is not audio visible.
Okay, okay. Fine, fine. In fact, I'll ask him to, what you say, speak a little louder. But were you not able to hear anything, Niranjan, there in Bangalore?
A little bit faster you should speak, sir, because the sentence formation we are facing problem to understand.
No, I feel basically, Niranjan, what I realized when I talked to you also, I think there's some problem with your speakers there, Niranjan. I think, you guys will have to maybe get some better speakers because
Okay, sir.
I think there's some kind of a problem there. And, when I talked to you also, I realized that, your voice is really low. So I think there's some problem there with the speaker than with him speaking.
So
Because
your voice is clear actually. Sir's voice actually need to speak a little bit faster so that understanding will be easy for us.
Okay, sure, 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 sure. Maybe I'll sensitize him about that. So tomorrow you should see. So tomorrow we'll
Yeah.
see you guys at 2 o'clock then.
Okay, sir.
Okay. And thank you all for attending it. And I'm sure, after this, you would, in any case, what do you say, have the video, we'll have this recording, put up so you guys can download it and, you can hear it. So thank you, everybody.
Thank you, sir.
Thank you, sir.
Thanks, thanks.